Good evening, all. Welcome to One Mark Solution again. Now we are going to deal with assertion and reason. Before that, please subscribe, like, and share to all your friends. It will be useful for you, no doubt at all. You will get at least 1 mark for you. Here, assertion and reason, we are focusing. Why? Because you know that the two new things in the board includes the assertion and reason and the case study. So let us start with assertion and reason under the topic electrostatics, that is the unit 1. Now we can go for the first question. You can see that assertion and reason. Before going for that, you should have an idea about what is assertion and reason. So first of all, you have to go for the ABCD. The first one, both assertion and reason are true, and reason is the correct explanation of the assertion. That is, if both are true and both, that is, the second one is the correct explanation. The first one, we can write A. The second one, if both are true and the second one is not the correct explanation of assertion A, then we can go for B. And the third one, we can say if A is true but reason is false. And the fourth one, we can say if assertion and the reason is false. So please have a thorough study of this so it will be easy for you when you are writing the answer for it. Now we can go for the first question. You can see the assertion. A proton is placed in a uniform electric field. It tends to move along the direction of the electric field. Why it is tending to move along the direction of the electric field? You should know that, isn't it? That means when a charge is placed in an electric field, it will experience a force. F is equal to QE, and it's a proton, positive charge, so positive QE. So sure, it will go along the direction of the electric field with a force plus QE. Now we will see the reason. What is the reason here? It is given. A proton is placed in a uniform electric field. It will experience a force, right? It will experience a force, but can we say that is it the correct answer for that? No. Why? Because you should say that proton is positive also. So what will be the correct answer? A is not the answer. B. Why? Because A and reason is correct only. Proton is experiencing a force, but we have to add what is it? The charge is positive also, but it is not written. That is why we can go for the answer B. That means A and B are true, but the reason is not the correct explanation of assertion A. Now we can go for the second question. Now, the second question is the assertion. We can say electric field at the surface of a charged conductor is always normal to the surface at every point. This is one of the very important topic. That means one of the topic of the electrostatic of conductors. In the electrostatics of conductors, 6 points are there. Out of this is one of the very important topic. Always it is normal to the surface. Now, what is the reason behind they are giving? Electric field gives the magnitude and direction of the electric force experienced by any charge placed at any point. Can we say this is the correct explanation? No. We have to say some other explanation. What will be the explanation here? We can say the explanation here we can say is electric field it's at the surface of a charged conductor is always. But if it is not always, that means if it is not normal, what will happen? The components will be there. The component of the electric field will be there. If the component is there, what will happen? The charge will experience a force, though they will start moving. In the static situation, no charges are moving. So it is actually not correct. That means contradictory. That is why here we can say that it is always normal to the surface. So the reason given is not correct explanation for assertion. So which is the answer? Answer B. Now we can go for the third one. Third one, assertion, we can say the potential inside a hollow spherical charge conductor is 0. No, not at all. Why? Because the potential is constant throughout the volume of the conductor. This also you will get from the electrostatics of conductors. I'm repeating again and again. Why? Because please study electrostatics of conductor, the 6 points you will get any one of question. The second reason also, we can just go for the reason. Inside the hollow spherical conductor, electric field is constant. Just think it of. Electric field, is it constant? Not at all. Electric field is zero. So just opposite the here it is given. So assertion and the reason also false. Potential inside a conductor is constant, and the second one reason we can say the inside the hollow spherical conductor electric field is zero. That could be the answer. But here both are given as false. So the answer is D. The option D. Both are false. Now we can go for next question. See that assertion. Electric field lines not form closed loops. They are not forming closed loops. Why? Because if you are taking inside a conductor, electric field is zero. If you are drawing the electric field lines, it is from positive to negative. But they will stop at the ends. It won't come through the conductor. Why it is not coming through the conductor? Electric field is zero, so there is no electric field lines. So that is why electric field lines not formed closed loops. And reason is given is electric field lines are always normal to the surface of a conductor. No, it is not the correct explanation for the assertion. So the answer is, you can see the option P. The answer, the reason, actually what is the reason? There is no electric field inside the conductor, so they are not forming closed loops. Now we can go for the next question. What is the next one? No work is needed in moving a test charge from one point to the another over an equipotential surface. Equipotential surface. What do you mean by equipotential surface? Potential is equal. So the surfaces having equal potential, we will call it as equipotential surface. So if you want to bring a charge from one point to another, W is equal to delta V into Q. What is delta V? The change in potential, that is equal to zero. So work done also will be equal to zero. We will go for the reason. We will just read reason and we will see what is the answer given there. Electric field is always normal to the equipotential surface. That is another point, another property of the equipotential surface. That is not the correct explanation of the assertion. So the answer is B. Both assertion and reason is correct. These two are the properties of equipotential surfaces. But the reason is not the correct explanation for the assertion. So the answer is B. Next, we'll go for the next. Assertion. No work is done in moving a point charge Q around a circular arc of radius R, at the center of which another point charge Q is located. A charge is located at the center, a charge Q is located. So it is, what is it? Around a circular arc of radius R. So anyway, it is equipotential surface only. We can say no, equipotential surface. So any work is needed there? No work is needed. Charge is placed. So we can say the radius R is in, the distance will be same. So they are having equipotential. So no work is done. That is the assertion. Now we can go for reason. What is the reason? No work is done in moving a test charge from one point to another over an equipotential surface. That is the correct explanation. Why? Because just now we have discussed, isn't it? Equipotential surface, no work is done. So here also the correct explanation is given for the assertion. So the answer is, the option is A, we can say. Now we'll go for the next one, that the seventh one, assertion. A metal plate is introduced between the plates of a charged plate capacitor. Parallel plate capacitor only we are focusing. In this parallel plate capacitor, we are introducing a metallic plate. So what? Its capacitance is increasing. Why it is increasing? The equation for the, what is it, capacitance of a parallel plate capacitor is A epsilon 0 by D. But when a metallic plate is introduced, the equation will be a conducting plate. A metal is a conductor. A conducting plate is introduced. The equation for the capacitance becomes A epsilon 0 divided by D minus T. T is the thickness of the plate. A epsilon 0 D minus T. So what will happen? The denominator is decreasing. So altogether, the what is it? The value will be increasing. That is why the capacitance is increasing. Now we'll go for the reason. Is it the correct reason or not? A metal plate is introduced between the plates of a charged parallel plate capacitor. The effective separation between the plates is decreased. Of course, correct. D minus T. From D to D minus T, it is decreasing. That is why the capacitance is increasing. So option is A. Why? Because both are true and the first one is the correct explanation of the assertion. So option is A. Now we can go for the eighth question. Assertion. Earthing provides a safety measure for electrical circuits and appliances. Of course, we know that, isn't it? Why? Because if anything will happen, all the charges will go to the earth, directly to the earth, not to our body if you are touching that. Now, what is it? The reason given. When we bring a charged body in contact with the earth, all the excess charges on the body disappears by causing a momentary current to pass the ground through the connecting conductor. Of course, we know that. Why? Because if you touch it, what is happening? The charges, if you touch it, will go through our body also, isn't it? If you are putting earthing, what is happening? Directly, they will go to the excess charge. If any excess charge is coming, excess charge means what is it? The flow of charges is current. The voltage will be there. You know what will happen if that voltage will flow through our body? What will happen? You know that, isn't it? So for the safety measure, we are putting the earthing. You know the 3-pin plug. The third one is for earthing. So earthing means you know that excess charge will flow to the ground and earth is ready to accept all the charges. So here the reason is the correct explanation for the assertion. The option is A. Now we'll go for the ninth one. Assertion. The net force on a dipole in a uniform electric field is zero. The net force on a dipole in a uniform electric field is zero. Electric dipole moment is a vector directed from negative to positive. Okay? Negative to positive. Dipole, what is the direction of dipole moment? From negative to positive only. But here, the net force on a dipole in a uniform electric field is zero. Why it is zero? In a dipole, we know that positive and negative charges are there. So when it is placed in uniform electric field, what will happen? They will get a plus QE and minus QE. So total force will be equal to zero. Total charge will be equal to zero. So the reason is not the correct explanation. Is it the correct explanation? No, it is not the correct explanation of the assertion. Now we can go for the next one. The electrostatic forces are conservative in nature. What do you mean conservative? Conservative means what is it? We can say the work done by one of the main important property of conservative forces. Work done by electrostatic force. It is not that one. Work done by conservative force is independent of the path. That is a correct one. Conservative property of the conservative force is work done by the conservative force. It is independent of the path. But here it is written, the work done by electrostatic force is path dependent. So we can say the answer, it is not correct. Is it clear? Now we can go for, that is, here the reason is not correct. So the assertion we can say electrostatic forces are conservative, no doubt. If positive and negative charge is there, we can say that they are not, the force is not going in a path, isn't it? So that is why we can say conservative. Does not depends on path. It is purely conservative. So assertion is purely correct, but the reason is not correct. It does what? Why? Because it is just opposite. So it is path independent. So the reason is false. The option is C. Option C, we can say assertion is true, but reason is false. Thank you for watching this 1 mark solution. Again, I am reminding you, please subscribe, like, and share. Once again, thank you.